Hi everyone, my name is Wilbert Lancelot S. Aguilar from DCPET 31, and today I'm going to share my reflection about chip manufacturing and future technologies. After watching the videos of chip manufacturing, I was honestly amazed by how something so small like a computer chip can involve such an incredibly detailed and complex process. At first, I thought making chips was just about placing circuits on a small piece of metal or silicon, but the video showed me that it's way more complicated than that. Every tiny chip inside our phones, computers, and even cars goes through hundreds of steps, from purifying silicon to layering materials, applying chemicals, and finally engraving patterns that are smaller than the width of a human hair. The part that really stood out to me was photolithography. Seeing how light is used to transfer circuit patterns, onto a silicon wafer felt like science and art combined. The precision it requires is insane. Just one speck of dust or vibration can ruin the entire batch of chips. That's why chip factories have those spotless clean rooms and highly advanced machines. It made me realize that even the smallest details matter when you're working on something at a microscopic scale. I now appreciate just how interdisciplinary chip manufacturing is. It's not just electrical engineering, but also material science, chemistry, mechanical engineering, optics, thermodynamics, and more. I gained a renewed respect for precision and cleanliness. Minute defects or slight deviation can cascade into large failures. This is a strong reminder for how in any design or engineering work, even UI and UX, details matter. The first video, How Microchips Are Made, showed the entire journey starting from something as simple as sand. I found it incredible that the same silicon found in ordinary sand is the foundation of microchips that runs smartphones, cars, and computers. The process begins with purifying silicon, then cutting into thin, circular wafers. Each wafer then goes through dozens of precise and complicated steps before it becomes a functioning microchip. The second video, photolithography, step by step, took me deeper into one of the most important parts of the process, printing the tiny circuits onto the silicon wafer. This is done using ultraviolet light, special masks, and chemical reactions. I found it mesmerizing to see how light is used to draw patterns smaller than a human hair. The alignment, exposure, and layering processes all have to be perfect. If even one pattern is slightly off, the entire chip might not function. It made me realize how much accuracy, patience, and expertise this field requires. Then the third video, How CPU is Made, brought all it together. It explained how millions, even billions, of microscopic transistors are connected on a single piece of silicon to form the Central Processing Unit or CPU. The CPU is like the brain of every computers, handling every calculation, every program, every piece of data. Watching how it's made, from wafer to packaging, gave me much respect for the engineers and scientists who dedicated their lives to developing this technology. The amount of testing, polishing, and quality control done before a single chip leaves the factory is mind-blowing. After watching all this, I realized something deeper. These microchips are not just about technology. They are a reflection of human dedication, creativity, and innovation. Each stage of chip manufacturing reminded me of life itself. The purification process of silicon made me think about how in our own lives we sometimes need to go through challenges or refine ourselves to remove impurities, distractions, and mistakes before we can grow stronger. The photolithography process, where patterns are carefully printed onto the wafer, reminded me how the experiences we go through etch patterns into our lives. Every lesson, success, and failures forms part of who we are, just like how every circuit on a chip contributes to its overall function. The assembly and testing process symbolizes how patience and perseverance pay off. The engineers don't give up after one failed test. They test thousands of times until the chip works perfectly. That's how we should approach our own goals with patience, persistence, and continuous improvement. These videos also remind me that behind every piece of technology we use, there are thousands of unseen hands, scientists, engineers, designers, technicians, are all working together with a common goal. It made me appreciate how much teamwork and precision go into building the tools we often take for granted. When I hold my phone or use my laptop now, I can't help but think about the countless hours of design, testing, and problem solving that we went into making those chips work flawlessly. It also reminded me of the power of innovation, how humanity has learned to manipulate materials at the atomic level to build machines capable of thinking, calculating, and learning. It's also humbling to realize how far we've come as a species, from using sand and metal to creating the foundation of artificial intelligence, communication, and modern computing. Personally, these videos taught me the value of patience, attention to detail, and respect for the process. Sometimes we rush through our work or expect instant results. But, but just like in chips manufacturing, great outcomes takes time, precision, and care. Every small action we take, whether it's studying, practicing a skill, or working on a project, contributes to a larger result. It reminded me that small efforts, when done consistently and carefully, can lead to something powerful and meaningful. I also learned to appreciate the invisible work that happens behind every success. Just like how no one sees the countless tests and adjustments made inside chip factories, people often don't see the struggles, planning, and effort behind someone's achievements. Yet, it's that it's that unseen hard work that builds the foundation for success. In conclusion, watching these videos changed the way how I look at technology and even at life. They showed me that progress, whether in machines or in people, happens step by step. It requires discipline, precision, and teamwork. It's not just about reaching the end product, it's about respecting the journey that gets you there. From sand to silicon, from circuits to CPUs, each stage is a story of transformation. It reminds me that greatness doesn't happen overnight. It's the result of thousands of careful, deliberate, and patient steps, and that's the lesson I'll carry forward. Not just with understanding technology, but in how I approach my own goals and dreams. And That's all for my reflection about chip manufacturing and future technologies. I hope you like it. Thank you.